So today we'll see the last point of this chapter. We'll see the resonating structure of carboxylate ion. Carboxylic acid is RC double bond O and OH. By losing H plus, there is formation of carboxylate ion RCOO minus. So this is carboxylate ion. The resonating structure shows that here the negative charge that is produced on carbon will form a double bond here. It will form a double bond here, and this double bond will break and the electron density will go towards the oxygen, and you will get this type of a structure, double bond between this oxygen and carbon, and the other oxygen which was having a double bond will now carry 3 lone pair of electrons and carry a negative charge. So these two are resonating structures shown with the help of double arrows. So as the electron density can be distributed, sometimes a double bond is formed between one oxygen, sometimes it is formed between other oxygen, carbon and oxygen, sometimes between these two, carbon and oxygen. We show the structure like this, that carbon, oxygen, oxygen, and we show a common dotted line. Dotted line is shown here, dash is shown, that the double bond is shared. Sometimes it is between this carbon and oxygen and sometimes between these two, and a negative sign is shown in between. So this becomes the structure. Now we are going to study the point of influence of electronic effects on acidity of carboxylic acid, that how the acidity of a carboxylic acid changes, which carboxylic acids would be more acidic and which would be less. So if we consider the simplest type of carboxylic acid, acetic acid, in this effect you will find that the 3 hydrogens which are present, or you can say that the R group, the methyl group that is present, that methyl group has electron releasing inductive effect. These groups have electron releasing. So what is the meaning? They release electron towards the COOH group. This will release electron towards the carbonyl carbon, and like that here there is plus I, that is electron releasing inductive effect present here, and the conjugate base which is formed by loss of hydrogen, the conjugate base, that is with a minus charge, the conjugate base which is formed, that base is not stabilized perfectly, and it has its pKa value 4.76. Come to second type of carboxylic acid, in which we have replaced one hydrogen of CH group by chlorine. So in spite of H, it is chlorine. So this is monochloroacetic acid. Monochloroacetic acid. What is the effect of Cl that is present here? Cl has got electron withdrawing effect. Cl that is attached to carbon, it has got electron withdrawing inductive effect, and due to that here the electron withdrawing inductive effect, that you call it as minus I effect, is making the conjugate base that will be formed by loss of hydrogen more stabilized as compared to acetic acid. Acetic acid's conjugate base इतका stable नसेल, but monochloroacetic acid's base has just the stable असेल, and it will have the pKa value as 2.86. It has that value. Now we come to the dichloroacetic acid. 2 Cl groups present, 2 H replaced by Cl. This group has, now 2 Cl groups are present, so the minus I effect, that is electron withdrawing inductive effect, will be more. Cl, 2 Cl atoms will pull the electron density from this carbon, ultimately from oxygen. Hydrogen is lost. So that conjugate base that is formed with a minus charge here, H is lost. The conjugate base that is formed, that base is stabilized more due to more minus I effect. More pulling of electron is there is more stabilization of conjugate base, and it has pKa value 1.26. In last case, all the 3 H atoms are replaced by Cl. So the minus I effect becomes maximum. All the 3 chlorine atoms are pulling the electron density towards them. So minus I, electron withdrawing inductive effect has become maximum in this case due to the presence of halogens which are attached to carbon. And in this condition, the conjugate base that is formed by loss of H, that minus charge on oxygen is stabilized. Very well stabilization of minus charge is there in this case, and hence the pKa value becomes 0.6. So this acid is found to be most acidic. This will be maximum acidic acid. This type of carboxylic acid, that is trichloroacetic acid, will be maximum acidic, most acidic acid. I have written here. Okay, it will be most acidic acid. So what do you find? pK values, lesser the pK value, more acidic the compound is. This is most acidic. आपण आता वरती येऊ परत डायक्लोरोएसिटिक ऍसिड मध्ये pK value is 1.26. So this is less acidic as compared to the last trichloro. आता वरती परत monochloroacetic acid मध्ये pK value 2.86. It is less acidic than the lower two. And acetic acid pKa value 4.76. It is least acidic because त्याच्यामध्ये -I effect नाहीच आहे. त्याच्यामध्ये the effect that is playing due to CH3 group. The CH3 group that is present is इलेक्ट्रॉन रिलीजिंग. म्हणजे ऑलरेडी इलेक्ट्रॉन आहे याच्यावरती आपण अजून इलेक्ट्रॉन रिलीज करतोय. तर द कॉन्जुगेट बेस विच इज फॉर्म, दॅट बेस विल बी लेस स्टॅबिलाइज्ड, व्हेरी लेस स्टॅबिलाइज्ड, अँड म्हणून हा ऍसिड हॅज लीस्ट ऍसिडिटी अँड लास्ट वन हॅज maximum acidity here. So such questions for 2 marks can come where you have to explain the concept on the basis of inductive effect. काही केसेस मध्ये प्लस आय चा इफेक्ट असेल. प्लस आय इज इलेक्ट्रॉन रिलीजिंग इंडक्टिव्ह इफेक्ट अँड मायनस आय इफेक्ट इज शोन बाय व्हॉट? हॅलोजन्स. मग सपोज इफ आय चेंज द हॅलोजन, सीएल पेक्षा आपण अजून दुसरा हॅलोजन घेतला की ज्याच्यामध्ये जास्त पुलिंग इफेक्ट आहे, इलेक्ट्रॉन विथड्रॉइंग, मग एफ आपण घेतला तर एफ मध्ये अजून इफेक्ट आहे पुलिंग, अँड दॅट विल प्रोड्यूस मोर ऍसिडिटी in the compound. If I take monofluoroacetic acid and monofluoro will be more acidic because fluorine has more electron withdrawing inductive effect. Minus I effect of fluorine is more than chlorine. So this is concept that should be understood. Now when we move towards the acidity, next point, acidity of aromatic carboxylic acids. Now aromatic carboxylic acid. The simplest aromatic carboxylic acid that we know is benzoic acid. Benzoic acid. In benzoic acid, the point that you must remember and make it clear that this is sp2 hybridized carbon. sp2 hybridized carbon. Here, this carbon is sp2 hybridized carbon. So the carbon which is sp2 hybridized has minus I effect. That is electron withdrawing inductive effect here. This group is withdrawing electron here. It is, the ring is pulling electron towards itself because this is sp2 hybridized carbon attached to sp, again the carbon that is present here, sp2 carbon, ring cha, it has got more electron withdrawing inductive effect. Now, so it has got pKa value 4.2. Now, if a group such as nitro group, chloro group, cyanide group is attached at para position. At para position, such groups are present. That is, in para-nitro benzoic acid, nitro group is present. Nitro group कसा आहे? Nitro group is electron withdrawing group. So nitro group is withdrawing electron. So it is pulling electrons towards itself. At the same time, the ring, this carbon, is also pulling electron towards itself. So electron pulling हा effect, minus हा effect हा increase झाला due to the ring phenyl group पूर्ण आणि nitro group. So that minus E effect, minus I effect has become more. Electron withdrawing effect has become more, and this is making the conjugate base more stabilized. इथे conjugate base stabilize होतोय, पण दोघांना आपण कंपेअर केला तर नायट्रो असेल, नायट्रो, क्लोरो, सायनो असा ग्रुप रिंग मध्ये असेल तर such compounds are found to be more stabilized because त्यांचा more acidic, because त्यांचा conjugate base कसा आहे? Stabilize होतोय easily. मग pK value in first case is 4.2, in second case it is 3.41. आता we'll see the last case. In last case you will find that benzoic acid has CH3 at para position. What is the point about CH3? We saw in acetic acid that CH3 group is electron releasing. You also call it as electron donating group. It is electron releasing. It is giving the electrons towards the phenyl ring. It is giving the electron. So the conjugate base म्हणजे हा इथे ऑलरेडी मायनस चार्ज येणार आणि अजून इलेक्ट्रॉन त्याला प्रोव्हाइड होतोय. So this will make the conjugate base less stabilized. This will make it less stabilized. Hence, it is decreasing the acidity. Which groups? CH3 group, OH group, OCH3, NH2. Such groups are electron releasing groups. They will donate the electrons. They release the electron because they are electron rich. NH2 ला lone pair of electron आहे. CH3 already electron releasing group आहे. OH ला lone pair of electron आहे. Electron releasing group आहे. Such groups will not stabilize the conjugate base properly. So the pK value becomes 4.4 and the acidity will decrease here. So I told you, more the pKa value, less is the acidity. Acidic strength कमी. मग 3 cases आपण compare केलं तर you will find that in middle case, that is in nitrobenzoic acid, para-nitrobenzoic acid, pK value is 3.41. So it is most acidic among the 3. In case of acetic acid, 4.2. None of the groups attached. कुठलाच group attached नाहीये याला. So the value here is 4.2. This is less acidic as compared to nitrobenzoic acid. And in case of the methyl benzoic acid, paramethyl benzoic acid, you will find the compound is least acidic because the pKa value is maximum here. And hence such questions can come that out of 3, which is most acidic, pK value will be given or it may not be given. But you should remember the groups. याच्यामध्ये एक पण ग्रुप नाहीये. याच्यामध्ये नायट्रो ग्रुप आलाय. नायट्रो ग्रुपची टेंडन्सी कशी आहे? It is electron withdrawing group. So it is pulling the electrons. Phenyl ring पण electrons pull करतोय. That is stabilizing the negative charge. जे negative charge ते फॉर्म होणार त्याला तो stabilize करतोय. पुल करून घेतोय. म्हणून इथे stabilization क्रिएट होणार. तुम्ही नेगेटिव्ह चार्ज आहे आणि अजून इलेक्ट्रॉन या केसमध्ये रिलीज होतोय तर अनस्टेबिलिटी or instability will increase and that will make it less acidic. So with this we finish the chapter of aldehydes, ketones and carboxylic acids.